Hello, this is Zach Knoll. This is for CIS210, Class 9, index searching. So we'll take a walk through. I used a couple things from last week's code. This just pulls everything in. I could probably clean it up more, but for now it works. And it's pretty quick, so we'll leave it as is for the time being. Pulls the list in from a file. This is just a print function just to check stuff, check the length of the list, whatever, you know. And then, so this makes the index, and how I ended up doing it was a combination of what you used, and then I also did some researching and stuff, and then kind of just figured out that when I needed to make my, so I originally had a bunch of different functions. One was the list, valued all the way out by itself, and then it just overwrote any duplicates with the next value where it showed up, which obviously that was a problem. And then I made one that did just duplicates, and then just non-duplicates, and then ordered it like sequentially. And I wasn't really happy with any of that stuff, so I found out that if I flip the values around, then I could go ahead and get my duplicates, and then so from there I was able to make my list, and you'll see that it works in just a sec. This most common thing was just what I threw in to do my benchmark comparisons between my linear searching, because I already had one written for most common for linear, so I figured why not just do this thing. So right now we're just running a list that it's 517. Actually, I'll open it up with the one that the notepad one. So it's 517 items, and then I purposely put a bunch of duplicates at the top, and then I duplicated that a bunch of times just to show that it works when it runs. So, and then it'll also spit out most common. So it's a pretty quick one. I think it was like 7 seconds, and it just printed out the whole list. So as you can see, the most commons 59, 53, and I organized the list as well. So we'll go 59, 53, and it's obviously, I didn't want that. And as you can see, it's in 0, 1, 2, 3, 4, which is obviously 1, 2, 3, 4, 5, and then it also is in 18, which would be spot 19, which is right there. So as you see, it works. I could do that for any size list, and I mean, when the print function's turned on, the time is really a matter of how long it takes for it to output to the screen. So I've been usually leaving that turned off to work with the rest of the list, because I don't have it turned on in the other program either. So, and then I'll just show you real quick that it works for large lists. That's 517. This folder that I'm about to run is actually your original list, so 99,999. And as you can see, grabs the most common number out of the list, because that's what it's asking to do, and that's how long it took. So as you see, less than 1 second. And then here's my, just to show a quick comparison, here's one of my linear ones. So everything's shut off except for most common, so there's going to be nothing else interfering. And just to show the time difference, we'll run my list of, I have a list made of 10,000 integers as well. And because obviously just, searching like 1,000 doesn't take long no matter what, it's just a small list. But this one, as you'll see, has some difference, because the other program had already run through just shy of 100,000, whereas this one took 7 seconds to sort through that. And just to show you that it works the same, we will go ahead and load that up really quick. So 10 KOS, and as you see, they both grab the same number, just an insanely different amount of time. So then, as you can see, it's all graphed out, which I'll include this week in the submittal. So yeah, enjoy.